this is not your first time being introduced to end behavior. So if you remember last year when you had like negative x squared plus 5x, let's do plus, I don't know, let's do plus 6, okay? So when you graphed that, you probably preferred it in vertex form or intercept form, but anyways, you looked at the leading term, and that negative helped you decide if the graph was going up or down, right? And so because it was negative, you knew that it went down. All right, so what if you have higher degrees? So let's first, real quick, go through and find the leading term. Now, I do a more in-depth video on this, so go look for that if you need a more in-depth video on this. But the leading term of this one's going to be 2x to the third. So I don't care about anything else when I'm determining end behavior except for the leading term. The leading term here, because it's in standard form, is going to be negative x to the third, 7x to the sixth, and this leading term will be negative x to the fourth. Okay, so that's all you need. You don't need anything else to know the end behavior. So the end behavior is determined, again, by two things. It is determined by the degree and the sign of the leading coefficient. Sign meaning is it positive or negative. So here we have a positive leading coefficient, and then we have an odd degree. This one is also odd, but in this case it is negative. Here we have a positive, 7 is positive, right? And then 6 is even. And then here we have a negative negative 1 is the leading coefficient. And then the degree, negative. Out in front, leading coefficient is negative, and the degree is 4, which is even. Okay, so our end behavior, we have 4 options, the ends of our graphs. It can either go up, up, and I'll do other stuff in between, right? But up, up, down, down. It could also start down and then go up, or it could start up and then go down. We'll get into a more formalness of that later. But what you're going to remember is if it's odd, the ends are going to point in opposite directions. So for example, the first one that we did, 2x to the 2x cubed, the end behavior is going to point in opposite directions. Now positive is going to help you know that it is a positive slope. So it'll go like this, okay? Positive slope. As you go left, right, it's going to go up. This one's also odd, negative x to the third. But because it's negative, it's going to be like a negative slope. This one is positive, okay, but it's even, which means they will end pointing in the same direction. Now, again, there's other stuff going on. Okay, we could go back here. There's other stuff going on. But the ends, because it's even, will both be going up. So last year you did all x squareds. You did all quadratics, right? That was an even degree, so they all pointed up or down, all in the same direction. Odd is opposite. So positive, even. Okay, now negative, even, that you already know that. You're familiar with that, both down. Okay? All right, so once you've mastered finding that, all you got to do is just, before you start the test, just draw this little thing to remind you. The leading coefficient, x to the n. Okay, so n represents the degree, and a represents the leading coefficient. So if n is odd, we know that it'll go in different directions. If n is even, we know that they'll both go the same direction. Either up, up, or down, down, okay? Now the other part is by the leading coefficient. So if a is positive, it'll be like a positive slope or both up. And if a is negative, it'll be like a negative slope or both down. Okay? Now, how do we translate this to math language called limit notation? What we do is you're going to say the limit as our x's go to the left, or x's go towards negative infinity, the function is going to go to, now it depends on what you're saying. So if we want to describe this going on, so as we go to the left, it's going down to negative infinity. It's the outputs are going to be negative when we get clear to the left of the graph. So basically this says left in just spatial reasoning, and this says down. Okay, well, what if I wanted to describe this end behavior? Okay, so I'd say the limit as x goes to negative infinity, right? So we go towards the left, the more negative inputs, then the function, so as we plug in bigger and bigger negative x's to the left, the function is just going to get more and more positive and bigger and bigger and bigger. And then on the right-hand side, the limit as x approaches positive infinity, the function will still remain positive. So remember, the x-axis, if we head to the left, it's heading towards negative infinity. If we head to the right, it's headed towards positive infinity. On the y-axis, or f of x axis, same thing, right? This is going to be to positive infinity, and this would be to negative infinity.